Hello, and welcome to the On-Premise IT Roundtable, the only podcast that dares to be both on topic and on location. My name is Tom Hollingsworth, and I'm a part of Gestalt IT. And each episode, we try to bring you the opinions and thoughts of some of the luminaries in the networking, security, wireless, storage industries to debate a premise or some kind of an idea in technology. And hopefully we learn a little bit about it. I'd like to take a few moments to introduce today's guests, and then we'll get to this episode's premise, starting with Justin.
Hi, I'm Justin Warren. I'm the founder and chief analyst at a little consulting company called Pivot9, based in Australia. And you can find me online on Twitter at JP Warren.
Thank you. Peter Jan?
Hi, my name is Peter Nefkens. I'm a Dutch consultant, and you can find me on Twitter with @PJNef or on my blog site, nefkens.net.
And Zoe.
Hi, my name is Zoe Rose, and I do security consulting, I suppose. You can find me on Twitter at RoseSecOps, or you can check out my website, rosesec.com.
All right. Thank you all for joining us in this virtual premises today. Like to jump into the premise of this episode. So we've heard a lot about AI and machine learning. I'm pretty sure you can't throw a rock anymore without hitting some startup that's working on it. On our episodes of the Gestalt IT Rundown, we often talk about the latest advances from Google or other companies that are doing interesting things. But it tends to fall down a little bit when we get into actual implementation. It's all great to do machine learning research, but if you're not doing something with it, you're not making money with it. And that's where we tend to run into some problems because not all things are well adapted for machine learning. And so when you come to the enterprise, is there really a good use for it? So the episode's premise is that the only good use of machine learning in the enterprise is anomaly detection. So Justin, you and I have actually had some pretty fascinating discussions about machine learning in the past and the foibles that people are going through to try to implement something super theoretical. Do you think that anomaly detection is really the only use for machine learning in the enterprise?
Maybe, possibly not even that, really. Most of machine learning's bollocks. It's glorified linear regression most of the time, or better yet, it's just nested if statements. Most of the time, you don't actually need that, honestly. 90% of the stuff that enterprises could benefit from, you could do with Excel. They're not even doing that properly. So going and spending huge quantities of money on some nonsense machine learning algorithm thing because a vendor says that it's cool. Like, do you remember big data? Remember then that was huge? Yeah, didn't that go well? This is just big data with some new stickers.
I think my favorite description of machine learning of all time was one of the presenters at Tech Field Day said, it's what an infinite number of people could do with an infinite number of Excel spreadsheets. And that's never been a more apt description that I've ever heard. Now, Peter, you are very tied into the operational side of things, especially with security. We were having a discussion earlier about, kind of how deep you dig into things. Do you feel like that machine learning is applicable for anomaly detection and well, that's pretty much it?
Well, I think it's not only applicable for anomaly detection, it's applicable for more things, but anomaly detection, absolutely, because machine learning is not a set of nested if statements. It's more than being just true or false. There are a couple of sort of is true, sort of is false. They're like grades, and then you put that in a model, and then you put the data through it. And then there might be something coming out of it. Still not unsure. And obviously with machine learning, it's the same. The quality of the answer is based on the quality of the model that you're using or the neural network that's effectively behind it. And the question that you ask, it's the same with big data. And you can absolutely use it for anomaly detection. That's already proven.
Okay, well, that's fair. I mean, now I'll tell you that one of the things that, and this is something Justin and I have talked about in the past, it feels like that the hello world of machine learning algorithms is facial recognition. And as much as I love seeing people being able to pick faces out of a crowd, how do you operationalize that? And I think that that's maybe where the breakdown happens is theoretically, I can do a lot of things. Theoretically, I can make a phone call on my iPhone. Realistically, I don't really do that compared to all the other applications that I run. Now, Zoe, when we talked about this topic originally, you had jumped out there. You're like, yes, I am very pro this, and I want to talk about this. What are your thoughts around this? Is this, is machine learning basically just a wash, except for, hey, we can pick out some random things that are happening in log files that nobody has time to read through?
So I've got a mixed opinion. My opinion is one, Peter, your comment about it's not if statements. Is it then case statements? But but basically, if you've ever read the book Hello World by Hannah Fry, she goes into detail about machine learning, AI, algorithms. She's bloody brilliant. But the really big thing that kind of sticks out to me is she talks about bias, and your comment about having the proper data input is very important. And I think at the capability that we are at today, I think machine learning, the big benefit is coming into with recognizing anomalies. I can't say the word. I think that I would limit it to that because that's where we're at. We don't really understand it. We like the catchy phrase, but we don't really know how to apply it properly. And a lot of the data that we're putting in is very biased. And so the outcome is bias. It's bad. We fudge up a lot of things, and there's been situations where it's been impactful to people's lives. So in the book that I brought up in Hello World, she talks about how it was used in criminal law and it fudged that up. It was used in deciding, how much somebody should get for their financial support for medical reasons. And it was this nifty new tool that you can't question it. And guess what it was? It was an Excel document with a little bit of extra added in there, and it fudged it up. And it was because, that's what we do. We're really good at making mistakes. So I think machine learning at the point today where we are and what we can do, yes, that's why it's only good for that, is because that's all we're capable of doing at the minute.
So let's jump on that a minute, because it's kind of funny. We're talking about this from a security perspective because we're all security people. We see machine learning as a way to solve a problem of being able to pick out things that look, not right in a set of log files. Or there was a recent article that Microsoft and Intel are training machine learning algorithms to look at 2D image representations of executables to find malicious code to determine that. And, we've got a 99% hit rate on being able to find, ransomware executables. Okay, that's great. I don't know how to operationalize this. But to your point, Zoe, I mean, one of the problems that we have is if machine learning is doing bad things or giving us data that doesn't make sense, how can we track down that the algorithm is flawed or busted, or that the data set used to build the training algorithm was inherently wrong to begin with, and so all of the data that's coming out of it is suspect? Can we trust machine learning to even tell us if the anomalies are bad?
I use it as an additional, when something's picking up an event like a seam, it's saying, oh, there's this event, check it out, I think it's bad. I'm still validating, is this actually accurate? Maybe it takes some actions because it could be, this is potentially a really bad thing, so shut this down just in case, but it's still getting that human interaction. And your comment about, in her book, Hannah Fry brings up how actually the thing that was better at identifying breast cancer cells in scans was pigeons. So I think that it's a great book. I'm just selling it here. But I think that the biggest thing is, yes, there's benefit, but we need to apply it properly to our capability, and we're still going to need that human bit because we don't know if we've done it right. We don't know if we've applied it properly, and we don't know if there's a little bit of a inaccuracy in it, I guess, if that makes sense.
Peter, oh, go ahead.
Yeah, we need to understand or be aware that it's completely overhyped at the moment, and that the expectations are so high that they're not impossible to do. When I was at my university, they had a neural network, and it was learning for like 2 years, and then it started to say "da" out of its own. That's something a baby does in 2 or 3 months. Okay, so that was 20+ years ago, but even then, technology is not that far yet. But going back to the anomaly detection, from a practical environment, not security, but operational wireless, I've heard from a customer, and they provide CAT services on a roaming service. And every morning, their wireless network health is a score of 1 to 10, roughly about 7 a.m. in the morning, every single morning. And why? There's a train station nearby. And actually, everybody who is going onto that train, well, perhaps not because we're now working from home, but in the past, they were actually coming in the train station, and your cell phone tries to connect to that roaming environment at the back. So your wireless health is going down to 1. So your security event or your operation event says, hey, your wireless is operating badly. And then your neural network or your anomaly detection can say, hey, this is a pattern. Every morning at 7 o'clock, I have so many clients that are too far away. That's normal behavior. So it's not going to give me that alert anymore. And that's a real use case that's actually happening already.
Yeah, people seem to forget computers are incredibly stupid. Like like this whole idea of machine learning is like they don't learn anything like humans. They're nothing like human intelligences.
The
So
computer
this
never makes
whole
a
idea
mistake.
Sorry, what was that, Peter?
The computer never makes a mistake. It's the programmer.
Well, yeah, yes and no, and that's where some of the machine learning algorithms actually introduce greater sources of error, which is part of the problem. But to your point earlier, and what Zoe was saying, another great book on the same sort of idea, Zoe, is Weapons of Mass Destruction by Kathy O'Neill. I recommend that one. Another one called Algorithms of Oppression, which is worth looking at as well. Because there's this drive that we should let the computers do this for us. And part of it, I think, comes from the idea that, oh, we'll be data driven. We'll just ignore the fact that most of the data that we have is garbage, but we'll feed it into a computer and then magically it will become great. And then the humans who have until now been terrible at making data-driven decisions will magically start paying attention to the computers when it tells them to do stuff they didn't want to do. Like, really? Yeah, good luck with that. So the problem here it's not machine learning. It's like it's mostly trying to solve a problem that's not really solvable in that way. We need to actually go to the humans and look at the human systems. If we spend, I think we'd get a lot more value out of spending more time dealing with the human systems than trying to look for some sort of magical computer panacea.
I was just going to comment, Hannah Fry, I've seen her speak like 3 times as well, and what she always talks about is it's also the way we phrase it. So the way we phrase machine learning and AI and, all of this is we act like it's intelligent. It knows what it's doing. It knows what it's learning. It knows when we enter this data that that's not accurate, this is, and that's biased, and but it doesn't know that. It has no concept of that. It's not intelligent. And so the way we phrase it is very, very important, because we can't say, these are autonomous cars. We can say these cars can assist you, but it's not going to drive for you because it doesn't even know what a road is.
And the computer tends to be quite confident about its answer. One of my favorite things is Janelle Shane on Twitter does AI Weirdness, I think is her blog. She taught a neural network how to do D&D character names and various recipes and things. It's hilarious. But one of her favorite ones is to go to an image recognition thing, which like will describe a scene, and she'll just ask the algorithm how many giraffes there are. And it always answers, and it will say something like 2. It's extremely confident about how many giraffes there are in a picture of a cake, and there are no giraffes. So it just shows how completely stupid these things are, which is hilarious when it's being done for something that's not terribly important. But if you're putting it in charge of, for example, like your security intrusion detection systems, the risk or the consequences of it being wrong because you gave it bad data, or the algorithms are terrible, or you haven't trained it very well, or you were putting it in charge of something that's just not really ready for. We shouldn't be doing that.
I think that's actually a good point, Justin, because that's one of the things that I hear a lot. Because when we cross this over into automation, is typically when the argument starts getting really, really heated. I'm not going to trust a computer to make decisions for me and do things without my express approval or something like that. So extending the metaphor back to, using ML and anomaly detection as an input to IDS IPS, what happens when an IDS detects that somebody is connecting on a VPN outside of normal hours or something like that, and then it just terminates the connection. And then maybe you get an email at the end of the week going, oh yeah, we shut the CEO's computer down, 27 times because he was trying to VPN in from Hawaii because that was outside of his normal hours. And well, you probably would get the email from the CEO long before the algorithm told you that something was going on. But is that maybe the solution to expanding the use of ML in other things, is to not rely on it as a single source of truth, but kind of going back to what you said, Justin, maybe using it as an additional data source with a confidence level of saying, this looks weird, and I'm almost positive it's not normal, but you really should go check this out, instead of that whole, I am confident that there are 8 giraffes in this picture of an elephant.
Well,
yes and no,
sorry.
but I'll caution on that, because there is a known statistical bias from humans that we trust a computer, an automated system, more than we would some other data source. So even though you put a human in the loop, the fact that a computer came and said, there is a 60% chance that we are 60% confident that this course of action is good. And the human will look at that and going, sure, okay, send, why not? And it kind of absolves people. People feel absolved of having to make the decision for themselves. So yeah, you put the human in the loop, but they're not actually making a decision there.
But
They're just pressing a button.
But you're basically referring to the confirmation bias. The computer says or something tells me, and I probably assume that. So the human is looking for confirmation because that's easier.
There's 2 things to that. One is that percentage of confidence. So going to like the image detection, a lot of the software that you'll use, it will say 60% we think that this is that, or 70% we think this is a human and it's not. And that kind of, helps me kind of set the tone a bit better. But the second one is the way we preface it, the way we kind of present this. And the really good example that I've heard a few times, but also mainly in that book I mentioned, is cars is a great example, because it's, Tesla presents these cars as self-driving 100%, and they'll have they've had not a ton, but they have had accidents. Whereas other types of cars, and I'm not just picking on Tesla, but other types of cars also have similar features, but they don't present it as these are 100% autonomous. They need our help. They can only do this amount to assist. And so I think that presentation and the way we present it is very, very important. Because when I started in security, and I started learning about events and incidents and what a false negative and a false positive is, when I first started, I was like, okay, so we teach it, that's an event, that's a bad thing, and therefore we need to investigate it, and it's probably wrong, like it probably is a bad thing. Whereas later on I realized, well, okay, but that only happens and can only be done and has less false positive, less false negatives, is if we've done it properly when we set it up. If that kind of makes sense, is we need to present this as this can do this because we've configured it properly, but also it can only do this much. You still have to validate that event is an incident.
Yeah, and I think that's where we need to be very careful when we're using these systems. So for a lot of the human use cases where it's actually affecting people's lives, a lot of the pressure on this around public policy is largely to say, when we're going to be automating some of these decision support systems, what we should be doing is the computer should only create a situation that is more beneficial to the humans. If it's going to be detrimental in some way, which could be it's recommending to send someone to prison, or it says, no, that's totally a bird, we should mow down the pedestrian because the economy needs us to, that shouldn't be permitted. And we need to be very explicit about that. So that so we need to have human decision making, and it needs to be transparent and interrogable and something that can be challenged before someone suffers a detriment. But if everything is done and says, yes, actually, we're the computer says that you should totally have $1,000 of government money every week. Who knew? That's okay. And that seems to be where, well, that's the policy sort of thing that I certainly agree with. And I think that we need to spend a lot more time looking at that before we start implementing these things willy-nilly.
But I think the biggest challenge there is, and this goes back to all security things in general, is a lot of times we say, do this, don't do this, do this, don't do this. And we don't say the why. And so I think when it comes to machine learning and whatever it is you want to automate, we need to teach them how it's working and why it may or may not be accurate, so that they can actually understand it before they just believe it and just trust it without question.
They still will, though. We can try. But humans are terrible at statistics, so yeah.
Yeah, but even then, I mean, if you look from network security perspective, there's so much data coming along, and networks are becoming more complex, all these flows, then machine learning can help to make a little bit more sense out of all the data that is now available. And whether the data is structured or garbage, if a human looks at, a human can perhaps 500 nodes have an overview of a network, but as soon as you're going to like 2,000, 4,000 endpoints on your network, you're not going to be able to cope on what's happening where. And that's where you can use machine learning. And since the premises is more about using machine learning in the enterprise, another good use case is object recognition. I've seen a use case in a demo where, for example, on the security footage, arms are being recognized. And then an alert can be sent in that some firearm is actually being pulled out of a car and somebody is moving with an active firearm to the company. So you can actually send off an alarm. And I think that's a very valid physical security use case to prevent casualties.
No, and I agree with that, but that's still adding a person, setting the alarm, but somebody's reacting. And I think that's the core of it, is the reason we're saying, the only good case is I can't say it. Essentially is, it's digesting all of this information and then trying to make sense of it. And I personally like to say to people that the most accurate person that's going to recognize something unusual is the person working on something day to day. So an end user that maybe isn't very technical, but they know what their job is, they know what's normal going on in it, and they can say, oh wait, that's weird, but I can't expect a tech to be able to do that for absolutely everything in the network. And so that's where the machine learning is benefiting them, but they still have to validate.
Even for the anomaly detector, how about this for an extended premise? We should, if we're going to use machine learning to look at anomaly detection in the enterprise, we should point the machine learning at the humans making the decisions to look for anomalies when they screw it up. So for example, like to use your I've detected a firearm example, I think what we should also do is look at how many false positives we get for when the IT department decides to have a Nerf war and security gets called on everyone and they end up having to have a difficult conversation with them because they decided to, because the machine said, yes, those look like giraffes to me.
And maybe that's the best point, is that machine learning is good at looking at things and noticing stuff that doesn't fit the pattern. And for so long, we have said to ourselves, well, if it doesn't fit the pattern, it must be bad, or maybe it's good, and that's what we want to see. But ultimately, doesn't fit the pattern is not a use case. Instead, it's a component of a larger discussion that needs to be contextualized. And I think maybe that ultimately is the value of machine learning, adding data for context for a decision to be made. So we might get there one day, but maybe that day won't come until whatever automated algorithm we've built learns how to apply some context. All right, well, that will just about do it for this episode of the Gestalt IT On-Premise IT Roundtable. Thank you all for joining and listening along today. We have more great episodes of this podcast over on our website at gestaltit.com/podcast. That's where the latest episode will always live. You can also find us in your podcast application of choice, whether that's the podcast application on Apple devices or Stitcher or even in iTunes. And if you're listening to us in iTunes, please head over there and leave us a like and a rating and possibly even a review. That is what helps people find this podcast and would lead to more great listeners and discussions of some fine premises in the future. So for myself, Tom Hollingsworth, for our great guests today, and all of the members of the Gestalt IT family, we bid you a fond adieu and stay tuned because more great premises are headed your way.